This video I am going to introduce the subject control system. First of all, let's see about system. What is mean by system? System is a combination of number of equipments or components connected in a sequence to perform a specific function. That is, number of small components are connected together to perform one particular function. For example, generally we called computer as a system because computer consists of number of components. That's our motherboard, processor, RAM, hard disk. Then also the input and output devices like keyboard, mouse, scanner, printer, then monitor, etc. Okay, here the number of components and each components also carry the small components. Okay, small electronics components. All components are connected in one particular manner to perform one desired function. So this is called as system. Okay. Then another examples in mechanical system, the automobile. Here also the number of components, the mechanical components are connected to perform one particular desired function. So that's are called system. Okay. Over here, what is mean by control system? Control system means in a system, when a output quantity is controlled by varying the input quantity, then the system is called control system. Okay. For example, here just a temperature control of the room. In a air conditioning system, we are set 26 degrees centigrade. The room temperature reaches 26 degrees centigrade means automatically cut off. Okay, the air conditioning system automatically cut off. Then water level control. In a tank, if we fix a water level system, the tank reaches the full level, automatically the motor supply is cut off. Automatically the motor switch is off. Okay. Then automatic ironing. Okay, some of the examples of the control system, general control system. Also, I am going to explain one bike riding system. Through this bike riding system, I am going to clearly explore the control system. This is a one automobile, okay, bike. Here, the bike is the mechanical system. Mechanical system means here the engine, the gearbox, then petrol tank, then the structure, the mechanical structure, then also the tire, two tires, then lighting arrangements, etc. Okay. Then here what is the output of the system? The output when the engine is started, what is the output? The desired output is the speed. It reaches some particular speed. Okay, speed. Speed is the output. Then what is the input? The input is the adjusting the acceleration. Okay, increasing the acceleration or decreasing the acceleration. Okay, so that the throttle valve of this petrol, so that the more fuel, if increasing the throttle valve, more fuel is injected to the engine. Less amount of adjustment in this acceleration, less amount of fuel is injected in the engine. Correspondingly, the speed of this vehicle is varying. Okay, but here in this bike riding system, I explain the two systems. Okay, the bike riding systems with speedometer and without speedometer. First case I am explaining without speedometer. Without speedometer, just to start the engine and increasing the acceleration by acceleration, the bike may go in particular speed. It may be approximately, we want to set the speed as 40 kilometer, but the speed is not actually in 40 kilometers. It may be approximately in 40 kilometers, may 41 kilometer or 45 kilometer. Okay, without speedometer case. Okay, the bike goes approximate speed. It's not in the accurate speed. That is, the output is not sensed by the human operator. The output of the output speed is not sensed by the human operator. Okay. Then another one case with speedometer. With speedometer, suppose want to go to the speed as 60 kilometer. Just look at the speedometer and manually adjust the throttle valve. Then set the speed is exactly 60 kilometer. Okay. Over here, Control systems are divided into two. One is open loop control system and another one is closed loop control system. In case of open loop control system, the output is not fed with input. That is, output is speed of this vehicle, the rotation of the tire, the speed. The speed is not fed with this input. The input is the operation, the human brain with the throttle valve adjustment. That is the input. Okay, the human brain not sense the speed. Okay, not sense the speed in case of open loop system. In case of closed loop system, the output speed is measured and is given to the speedometer by the use of the eyes and the human brain. We sense the speed and adjust depending upon the speed. You can adjust the throttle valve or this accelerator by set the desired speed. Okay, adjust here and the increasing or decreasing. Finally, is set the desired speed accurately. Okay, so here the control systems are broadly divided into two types. One is open loop control system, then another one is closed loop control system. Here, this is our Anna University syllabus. The first unit covers the systems and representation. The first, this class, I am going to explain the first two topics. The first topic is basic elements in control system. Then the second topic is open and closed loop control system. First unit covers the actual systems and their representation. Representation means this convert the actual system into the mathematical model or the transfer function model. The transfer function model or the mathematical model is the computer understandable model. Then only we can analysis through a computer before designing the system or any modifications in the system. We can analysis by using the computer. After that, we can design a large system and also reduce the complex system into a simple system by using block diagram reducing techniques and signal flow graph techniques. This much of topic will be studied in first unit. First of all, basic elements in the control system. It's maybe the system may be any system, the mechanical system or electrical system or pneumatic system, any system consists of these four basic elements: plant, feedback, controller and error detector. The plant is nothing, that is the system. Here the number of small components are connected in some sequence. It performs one particular function. Then feedback. Normally the feedback is the measuring device which sends the output, the system output or plant output. The output signal is given to the input or the error detector. The output is given to the error detector. This feedback signal is connected to the error detector. Normally the feedback signal is a negative feedback signal. The negative feedback signal is preferable. It gives stability and accuracy. Then what is error detector? It is a comparator. Error detector is nothing, that is a comparator. Compare the two signals. Any deviations in the signal, a desired signal and the feedback signal, the output signal, this give the output to the controller. Now let's see about controller. What is controller? The controls the plant is called as controller. The error signal will be weak signal. That is the difference between the signal, that is the weak signal, and so it has to amplify and then modify for better control action. In most of the system, the controller itself amplifies the error signal and integrates or differentiate to generate their control signal. An amplifier is used to amplify the error signal and the controller modifies the error signal. The controller, in most of the cases, the controller is the combination of amplifier and some modifier to modify the error signal, and it's give to the signal to the plant again, the plant, so that the plant performance is increased. Now let's see about open loop and closed loop control. The definitions are that a system which does not capable of correcting the changes in output by itself, it's called an open loop control system. The output is not corrected itself. I already explained through this bike riding system. The bike riding system is without speedometer, that is called open loop control system. The speed is not measured clearly without speedometer, not sensed clearly. The output is not accurate in case of open loop control system. The output quantity is no effect upon the input quantity because there is no feedback between output and input signal. So the operator does not know the output. The output values does not know. You give that output is not give a feedback to the input for correction. When a output changes due to external disturbance, then it's not followed by the change in the input to correct the output. Here some due to some disturbance in the output side, the output signal may change. Okay, here there is no correction in this input side. This is the planned and process is the that is the system. This is the open loop system. It's a simple system. Then advantages of open loop system. The open loop systems are very simple and economical. They are easy to construct. The open loop system is stable. The disadvantages of open loop system. The open loop systems are inaccurate and unreliable. The change in output due to external disturbance are not corrected automatically. Now let's see some examples of open loop system. First example, electric hand dryer. In case of electric hand dryer, the hot air comes out along as you keep your hand under the machine. If you keep your hand under the machine, hot air will come irrespective of how much your hand is dried. Suppose your hand is dried, you keep your hand long time under this hand dryer, hot air will come out continuously. When you take the hand, then only the hot air will cut off. An automatic washing machine. This machine run according to the preset time, irrespective of the washing is completed or not. Depending upon the cloth dirty or the number of clothes is not sense like that. Depending upon the time duration or water level, it's running. Okay, fixed time only it's run. Then bread toaster. It's also the time this machine runs as per adjusting the time respective of the toasting is completed or not. Then automatic tea or coffee maker. These machines also function for pre-adjustment time only. The particular time only it's run. Then time-based cloth dryer. Then closed loop control system. This is the block diagram of closed loop control system. The closed loop control system, the output is feedback with input signal. The control system in which the output has an effect upon the input quantity in such a manner so as to maintain the desired output are called closed loop control system. Here this is the output. The output is measured by using a feedback signal. This is a measuring device that measures and produces the signal. That signal is given to the error detector. The error detector compares these two signals and it produces the error signal. The error signal is going to the controller. The change in output due to disturbance are corrected automatically. Suppose any disturbance in this output side is corrected automatically. Then advantages and disadvantages of closed loop control system. The closed loop systems are accurate. They are accurate even in the presence of non-linearity. They are more stable. They are less affected by noise. Then disadvantages of closed loop system. They are complex and expensive because this closed loop system consists of additional components. Okay, the open loop system only consists of this one. The system only. Here this closed loop system consists of the feedback system and the controller and the error detector. So the cost of the system is more. More care is needed to design a closed loop system. The overall gain of the system is reduced due to feedback, because in the output side some other measuring devices may be connected. Okay, so the overall gain of the system is reduced. Let's see some examples of closed loop system. Automatic iron. Heating elements are controlled by output temperature of the iron. Here we set on particular temperature. That iron box reaches the particular temperature, automatically cut off the power supply to the heating element. Then servo voltage stabilizer. The voltage control operation depending upon the output voltage of the system. In case of servo voltage stabilizers. The stabilizers, its particular voltage, the output in the particular voltage means then only it's allow the input signal to the output side. Otherwise, it's cut off the voltage. Now the comparison of open loop and closed loop control system. Open loop control system, the feedback element is absent. The feedback element always present. Then error detector not present in this open loop control system. Here the error detector always present. These are the two additional components in the closed loop control system. The open loop control system is stable on, it may be unstable. When the feedback element collected time, the system may goes to unstable condition. Then easy construction, because it's a simple component, so it's easy construction. It's a complicated construction. It is economical because less number of components, so this is economical. Here more number of components, so it is costly. Having small bandwidth, here it's a large bandwidth, it is inaccurate. The accuracy, the output accuracy is inaccurate. It is accurate. Less maintenance, less components, so it's required less maintenance. Here more components are there, so it's more maintenance. It is unreliable. Unreliable. The output is not accurate, so it's unreliable. It is reliable. Example: hand dryer, tea maker. Already saw the examples: hand dryer, tea makers. Here the servo voltage stabilizers, etc. This video only discuss about introductions about control system, basic elements of control system, and open and closed loop control system. Thank you.